Okay, probability. With probability we have a scale, okay, ranging from impossible to certain, okay, and then in the middle then we have evens. We've got even chance, 1 in 2 chance of something occurring, okay. So impossible, we describe the probability then as being 0, all right. Whereas certain, if the event is certain to happen, it would be 1, okay. And then you've got a scale then ranging from 0 to 1, 0 impossible, 1 certain, and then anything in between then, the lower half, okay, is unlikely, okay. So for instance, if you got 1 in 4, right, 1 in 4 would go here, wouldn't it, as a quarter? That would be an unlikely chance, whereas here a likely chance would be if you had 3 in 4 chance, 3/4 chance, okay. Evens is in the middle, right, so you've got a half there, or 0.5 is also written as. Also percentage as well, it could be said 50% chance, okay, then you've got evens, right. Anything less than that is unlikely, going to impossible, or then above it is likely, and then going to certain, which would be 1. So if we look at this question here, Thomas has 1 spin of a circular spinner, shown below. 2 of the lines shown in the diagram are diameters of the circle. So you can see there the diameters, you've got this diameter here, 2 straight lines crossing. So in the table then, it says, below shows the probabilities of Thomas obtaining yellow, white and green with 1 of the spinner. Okay, with 1 spin of the spinner. So the probabilities of getting yellow is 0.2, probabilities of getting white is 0.12, and probability of getting green is 0.18. Alright, we are asked to complete the table to work out these here. Now, visually, you can see from here that actually the chances of getting red or green are identical, aren't they? Because you've got the same shape sector here, right? These sectors are created by these 2 diameters that cross here. So you've got 2 straight lines that cross. The angles are the same, okay? The opposite angles are equal, okay? Which means that this sector is the same as this. So this value, the probability of it landing on red, will be the same as the probability of it landing on green. The chance of it going to red is the same as the chance of it going to green. You can see then we've got the other elements given to us here, 0.2, 0.12. Green is 0.18, so straight away we can fill in red, can't we? 0.18, okay, because it's identical to green. We need to figure out blue, all right? You'd imagine there's more of a chance of this spinner landing on blue because you've got a larger sector, okay? But we can actually work it out perfectly because all the probabilities, all of the outcomes have to add up to 1, okay? They have to total 1 to satisfy this scale here, where 1 is certain. So what I would do is add up these decimals here, all right? So you've got 0.2, 0.12. So when you add decimals, make sure you line up the decimal point, 0.18, and then 0.18 again. So let's add up what we've got here so far, okay, lining up the decimal point. Now there's nothing there, so you can put a 0, all right? Add up these then, 0 plus 2 plus 8 is 10, plus 8 is 18, so that will be 8 carry 1. And then 2 plus 1 plus 1 plus 1, that's 5, isn't it, when you add them together, plus the 1 that's carried, that's 6, and then point, and then you've got 0 there. So 0.68 I've got so far. Now remember, all our probabilities have to add up to 1, okay? So we need to see what's left over now. In other words, we need to do 1, take away 0.68, okay, to see what the outcome will be for blue, okay, what the probability is for blue. Now when you do that, okay, you'll get the answer as 0.32, of course, okay. So that will be the probability that of getting blue. Blue, there's more chance of it landing on blue because it's the biggest sector, isn't it? Okay, so just remember they all have to add up to 1. So if you know majority of them here, you can work out the final 1 to see what's left. All right. Part B then, it says find the probability of obtaining either white or green on the spinner. Now here we're introduced to the sort of OR idea, the OR rule. When we have OR, right, we're opening up our possibilities, all right? We're actually including more of the outcomes in our question. Okay, so if I was just interested in the probability of it being white, I would just say 0.12. Okay, that's all it would be, probability of it being white. But if I include green as well, I've got more of a chance, haven't I, of it landing on one of them. Okay, so when it says white or green, okay, you'd actually think of them as both together then. Okay, so you've actually got more of a chance then of it landing on one of them. That's what you need to think about there. When it says white or green, one of them will do. It doesn't matter whether it lands on white or green. One of them is fine, right? And so you can sort of think of them then as going together, okay? One of those, if it lands anywhere there, if it lands over here or here, it doesn't matter. If it lands there, then it's gone on to white or green. So if we put them together, we need to add the probabilities together, okay? So when you see or in probability, you need to add. So the probability of being white is 0.12. The probability of it being green is 0.18. Add them, that will become 10, so 0 there, carry 1. 1 plus 1 is 2, plus the 1 is 3, and then you've got 0 there. So 0.30, and we'd write that then is the probability being 0.3, okay? And yeah, we've seen the OR rule there. The OR rule simply means that we add. Okay, we add the probabilities.